is an extension of trig from yesterday. We're doing angles of elevation and angles of depression. So you are doing all inverse trig today, okay? So first, we need to identify what is an angle of elevation and what is an angle of depression. So an angle of elevation is always measured from the ground up. It is always inside the triangle. So if you create a triangle with your horizontal and vertical lines, your angle of elevation is inside the triangle at the bottom. It is an angle between the horizontal line of the object or the observer's eye, the line of sight. In the picture, X marks the angle of elevation to the top of the tree. You can think of an angle of elevation in relation to the movement of your eyes. So whenever you just look forward, that's your horizontal eyesight. Okay? Angle of elevation would be like if it wants you to ask about looking up at a balloon or looking up at the sun or looking up at a plane. Okay? Anything you have to look up at is your angle of elevation. Okay? Yep, that's all that I just explained. Any questions there? All right, angle of depression. If the object is below the observer, then the angle between the horizontal and observer's line of sight is called the angle of depression. So it's outside the triangle. So notice we make our triangle with the two objects. If we are up here in the lighthouse, your angle of depression would be this line of sight first. So you have to see the horizontal. And then you look down at the boat, that's your angle of depression. So it would not be in the triangle. Does everybody understand? Okay. So with that being said, since horizontal lines are parallel, angle 1 and angle 2 are going to be congruent by the vocab that we have talked about, alternate interior angles. So therefore, our angle of elevation and our angle of depression are going to be congruent at all times. Any questions about that? Okay, so let's practice. First thing you need to be able to do is identify what's an elevation, what's a depression, or neither. So we've got a hiker up on a rock formation. He's got a bird out there in his sight, and he's got the ground below. So we want to identify, according to all these horizontals, what are angles of elevation and angles of depression, or neither. So angle 3, that's the bird's line of sight, and 3 is below his line of sight, so that would be an angle of what? Depression. Okay, number 4 is on the hiker's line of sight, and the angle 4 is above his line of sight. So what would that be? Elevation. All right, number 5. Angle 5 is also on the hiker's line of sight, correct? But the 5 is below his line of sight, yes? So that is depression. Angle 6, that tree doesn't technically have a line of sight, but it has a horizontal. And is the angle 6 above that horizontal or below it? Above it. So that would be what? Elevation. And I'm not sure what happened to my number 7. He is supposed to be right here. So angle 7. Is angle 7 on a horizontal line of sight? No. So if he's not on a horizontal line of sight, he's neither angle of elevation or depression. Okay, so that would be neither. So if your angle is not on a horizontal line, a line of sight, you're neither elevation or depression. Any questions there? Okay. All right, so now we're going to do word problems that deal with it. So similar kind of to yesterday. A ranger, 5 feet tall. So let's draw him. Got a ranger. He is 5 feet tall. He stands 100 feet from a tree. So he is 100 feet from a tree. He sights the top of the tree at a 40-degree angle. So before we can draw his angle of elevation, we need his what? Line of sight. Okay, so we need to draw in his horizontal line of sight first. And then we can draw his angle of elevation. So that 40, remember angles of elevation go inside the triangle from the horizontal line of sight and up. So we've got like a right triangle there, and we want to find the height of the tree. There's a little trick to this one. Can anybody see what else we need to add? What do you think? An X, yeah? Where would the X go? The tree, but is X the entire height of the tree? No. Right, just the portion above his line of sight. So what are we going to have to add in order to figure out the whole height of the tree? His 5 feet. Good. So this is 5 down here. The guy was 5 feet tall. We're going to do 5 feet as his eyeballs. Okay? I'm not going to count the rest of it. All right, so we need to find X. So we need to figure out which trig ratio is going to help us do that. So what sides do we have on that right triangle? Conchinto.
We have the opposite and the adjacent.
Good. So does everybody understand this 100 is also this horizontal? Those are the same. So if you've got opposite of the 40 is X, adjacent 100, what trig ratio is that? 10. So tan is, what are we doing? 40 equals opposite over adjacent. And then what do we do to solve for X? What have we learned? Multiply on this one. So X equals 100 times tangent of 40. Let's plug that in. What do you guys get? So 100 tangent 40. 83.9. Did everybody else get that? Okay, so 83.9. So then what's the height of the tree? Is it 83.9 feet? Good. So we got to add 5. So therefore, the tree is about 88.9 feet tall. Any questions there? Okay. Next, we've got 2 buildings. They're 30 feet apart. So let's draw building 1. Let's draw building 2. These 2 buildings are 30 feet apart. The height of the shorter building is 100 feet. So this is 100. The angle of elevation from the top of one to the top of the other is 19 degrees. So what am I going to need to add in here? The line of sight. And then we can create our angle of elevation of 19 there. So there's my right triangle. We want to find the height of the taller building to the nearest foot. What do we need to add to the problem? X. Where's that X going to go? Yeah, same spot as the last one on the right triangle for the building. And what are we going to have to do once we find that x? Add 100, because this is like a rectangle here. So we got 100 over here and also 30 up here. All right, so what trig ratio are we going to use for that right triangle? Tangent again, good. Told you tangent's probably the most common. So tangent 19 equals, what's our ratio? X over 30. So then times by 30, x is approximately what? 10.3. Anybody else get 10.3? Can I get a verification or no? Yes? Okay. 10.3. What are we going to have to do with that 10.3? Add 100. So therefore, what's wrong? The taller building is about, taller building is about how much? Okay, so that would be how much? 110 feet. Alright, sounds like some of you had to make sure you double check your calculators on degree mode. Otherwise you're not going to get anywhere near the right answer. Any questions? You'll learn that in pre-calc. It's more trig related. You've got a circle, that's your like trig circle, and it's got radians and degrees on it, and it's two forms of kind of like the metric system versus our system, basically like inches versus kilometers or meters versus feet, that type of thing. So it's just another form of calculating around that trig circle.
What do we do differently?
In this class?
Like feet and inches.
Oh, why do we not do the metric system? I have no idea. I honestly could not tell you why our government chose that instead of...
The rest of the world does the same exact thing.
Yes.
That can be different.
We're America. I mean, I don't know. I don't know what to tell you. We want to do our own thing, right or wrong. All right. Any other questions? Okay. Let's go to the last page then. Kind of forgot about this problem. All right, let's see if I can remember this problem off the top of my head. Otherwise, I may need to go get the book. So, Shane is 61 feet high on a ride at an amusement park. The angle of depression to the park entrance is 42 degrees, and the angle of depression to his friend standing below is 80 degrees. How far from the entrance are his friends standing? Round to the nearest feet. So, first thing says, redraw the triangles for step 1 and for step 2. So we need to redraw the triangles here. So we've got the right triangle that's really skinny. So it has 61 feet here. And his friends, I'm going to call this F, and he is Shane, so I'm going to call him S. So then I've got another right triangle here. And this is 61 again. This is Shane. And this is the entrance. Okay, so we know that from Shane to his friends was what angle of depression? No, to his friends was 80. So we know that angle is 80 there. Okay, and then we know from Shane to the entrance, what was that angle of depression? 42. And what did we say at the very beginning of the notes about angles of depression and angles of elevation? They're congruent. So where else can I put this 80 and this 42 in these triangles? Where would be its alternate interior angle? E and F. Good. So this is 80 here, and this is 42 here. Does everybody understand that?
Yep.
All right, so first thing it says on step 2, now that we have our triangles redrawn, is find the distance between the ride and the entrance. So which triangle is that? So this is the ride he's on, right here. So that's the blue triangle, right? So where's our X in the blue triangle? Bottom, right? So if I just real quick redraw this, we have 61, X is here, and 42's here. Does everybody understand that? So we're trying to find the distance between the ride and the entrance of the fair, park, or whatever we're doing. So what am I going to use to find that? What trig function will I use? What? Yeah, I do not have the hypotenuse. I have opposite and adjacent. So tangent again. So tangent of 42 equals, what would my ratio be? Opposite over adjacent would be 61 over x. And what do we do whenever we have x in the denominator? We divide, we flip. So x is going to be 61 divided by tangent of 42. So what do we get there? 67.7? Approximately. All right, so the distance between the ride and the entrance is approximately 67.7 feet. All right, next. It says find the distance between the friends and the ride. So which triangle is that? The small one, little skinny guy. So if we redraw that one, that's 61 and 80 degrees, correct? And then where does our x go? Bottom. So what are we going to do here? The same exact problem, right? Except we're changing the what? The degrees. So this is going to be tangent of 80 equals 61 over x. So x equals 61 divided by tangent of 80. So figure out how far is the ride from his friends.
Approximately
10 point what? Anybody else get that? Okay, approximately 10.8 feet. So the very beginning of the problem asked you to find the difference, or asked you to find how far his friends were from the entrance, correct? So what would we have to do, step 4? Subtract the two. So 67.7 minus 10.8. So therefore, his friends are about, how much? 56.9 feet from the entrance.
Oh, yeah, 6. We'll go 57. Oh, yeah.
All right, do we have any questions over that? So it does run to nearest foot? Okay, so 60 or 57? So 57 feet. All right, so I walked you through that problem. Just a heads up, there's going to be one on your homework that it doesn't have the multiple steps on. Okay, but I walked you through it here, so that way you understand it. Everybody got it? Okay.